And now we are diving into Azure. And why are we diving into Azure? Because believe it, this is the cloud that is picking up really fast. The way I see it, at least, or the customers I talk to. There could be a number of reasons, but I would say the prime reason is their enterprise insertion into those accounts, right, through their sales and whatnot, and then the services that they're offering. I mean, Office 365, the databases, this is what customers were using all along, right? So now they're moving it into the cloud, and customers are really interested in deploying their applications in the cloud. Okay, so let's talk about the 101 of Azure networking, because like AWS, Azure has a lot of services so cannot cover, obviously. So our main focus is going to be networking and security services. So what I have here is the architecture or the grouping that Azure created to club different resources, right? So in the Azure world, when you log into their Azure portal, the first thing that you would see is the top level domain. They call it AD tenant, Active Directory tenant, right? So in this example, I have the top level domain as for this company.com called corporate IT, right? And then within this top level, I can create subdomains or sub ADs like production, development, and QA. Now, when it comes to providing access to those resources, or they have something called subscription. So in AWS world, what you see as an account is called subscription in Azure. So yeah, same concept, different naming convention, but the way they implement things is also different in the background, right? So I'm going to teach you about these basic constructs, but as a networking and security engineer or architect, you don't really have to worry about those. But the problem is if you are just dealing with the console, then you have to, right? And this is where, again, Aviatrix has provided this abstraction layer for networking and security architects and engineers so that they don't have to worry about it. But you have to understand it a little bit, or to the levels where you can actually troubleshoot things if they break in the background, okay? Yeah, so I was talking about the subscription. And then within this subscription, you see something called resource group. So this is a concept that you don't see in AWS. So what they have done, they have clubbed everything in resource group. So for example, your virtual machine is a resource group, a resource, which is in a resource group. And then not only virtual machine is a resource, but also the IP address, the disk, the NIC card, everything that is associated with a virtual machine is a resource, right? And it goes on and on and on. So for everything, this is the model that they are following. So if you log into the Azure portal, what you see is a list of services, okay? So on their dashboard, they have a lot of services. So if you click on this services, you see services in compute, in networking, storage, container, databases, and then the list is long, okay? And then within that, they have, for example, if I click on compute, I can see they have a service called virtual machine, or a resource as a virtual machine, right? And then within virtual machine, when you click on it, you see all these different resources available as part of the virtual machine. So it goes actually very granular inside the resource that you define in Azure portal. So instead of me showing you this slide, let me take you to their portal and show you what exactly I'm talking about, right? So here I am logged into this Azure portal with my user ID. And on the screen, I can see on the left-hand side, I have a dashboard, the services. So these are the services I was talking about. So in the networking space, they have the virtual network. So that's the VPC. If you remember in AWS, the virtual private cloud, they call it VNet. So same concept, different name. The background implementation is also different. Then they have the route tables, they have the load balancer, they have the virtual network gateways, they have the ExpressRoute gateway. And if you go into the compute, then you will see the virtual machines, then you have the storage, then you have the database, and then within these these categories, you have all these different services available, right? So these are all the resources that I have. So let's say if I click on this virtual machine, which is a resource, you can see this virtual machine. It's a Aviatix Transit Gateway. It belongs to a resource group, right? Remember, I told you that every resource that we have, it belongs to a resource group. So that's the resource group you have, right? And within the resource group, you can see the resources available. So the disk is a resource. The public IP is a resource. The network interface is a resource, right? So that's how you see things in Azure Portal. Okay, let's go back to our slide. Right, so I talked about the resource group, the concept of resource group, and then the resources within a resource group. Okay. Okay, so now let's talk about 101 of Azure networking component. So again, on this picture, the picture that you see here is a very simplified version of their networking and security components. But yeah, let's talk about it. So what they have here basically is bunch of VNets, right? So that's the fundamental building block, or their definition of a virtual cloud, right? The VPC. So that's what they have. And then they have a concept of availability zone, AZs, what Nicholas also showed you on the screen, a large picture with Azure regions and then availability zones and whatnot, right? So those are like the data center within a region. Okay. And then the network security group. So in AWS, they call it security group. Here it's NSG. Okay, so this is your layer 4 stateful firewall. Okay, their concept of public and private IP address is not same as AWS. So in AWS, you have to create a public subnet, and then you point it to an IGW, Internet Gateway. Here, what happens that when you create a virtual machine, if you specify a public IP address to a VM, that means it can actually talk to the outside world. Okay, so that's different. And then they have this concept of virtual network gateways. And within this category, they have two gateways, the VPN gateway and then the ExpressRoute gateway. Okay, so what is the difference? So VPN gateway is basically VGW in AWS. It's about connecting your on-prem resources into VNet using a public internet. All right, so this is the simplest definition of a VPN gateway. But there are some nuances when you deploy this VPN gateway. So, for example, they dictate that when you deploy a VPN gateway, it must be deployed in a gateway subnet. So that's the name that you have to give to the subnet that you're creating. So you need to make sure that this is what you follow, right? And then obviously they have something called local network gateway, which is the on-prem entity. So it's not something that you see in Azure, but it's like the CGW, the customer gateway in AWS. So that's the equivalent. And number two is the express route. So now we talked about connecting your VNet to your on-prem resources, going over public internet, but obviously public internet has its own challenges. The bandwidth is the issue, the throughput is the problem, and then it's not like QoS enabled, obviously, it's the best effort. So for a lot of time when customers or enterprise customers, when they're connecting their VNets to on-prem data center, they go with the express route. That's their version of direct connect, which gives you a dedicated private lease line kind of a deal to connect your VNet to your data center, right? So when it comes to connecting this express route circuit into VNet, it actually connects to something called ExpressRoute Gateway. And we'll see this in a little bit more detail in coming slides. All right, so we talked about the VNets, we talked about how to connect to the outside world. What about connecting these VNets together, right? Or if I have some applications or virtual machines in VNet number one, and I want them to talk to VNet number two, what are my options? So this is where the VNet peering comes into picture. This is their native construct that they provide, so you can talk. But we know that VNet peering is not scalable. So if you have two, three VNet, that's okay. But when it comes to hundreds of VNet, then you're talking about creating a full mesh. And then in the routing space, they allow you to create your own static route. They call it user-defined route or UDRs. And then they have something called system routes, right? So those are the routes that are programmed, but unfortunately, you cannot see them in the Azure console or Azure portal. You have to go into the virtual machine. You have to see the associated routes. So it's a different troubleshooting path that you need to take. The last item you see on the slide is called NVA, Network Virtual Appliance. So obviously, we talked about VNet peering, and we know for a fact that we need some kind of a transit, some hub and spoke model. Otherwise, it's not manageable. It's not enterprise grade, obviously. So they have these network virtual appliances or virtual machines available in the marketplace. You can deploy it in VNet, and then they provide different type of functionalities. For example, there's the firewall NVA that can provide you the firewalling function or next generation firewall, right? And then also we have our own aviatrix gateways, transit gateway and spoke gateways, which are also NVAs, right? So a lot of customers are actually using our transit solution to solve these problems that we talked about. That's the example of NVA. Okay, so we looked at the different options or networking component. The last one here is the Azure load balancer. So in the load balancer category, they have the layer 4 load balancer, right? So that's what they have. And then you can also get something called application gateway for L7 load balancing. Okay. Okay, so how do these constructs or services they connect in a topology, right? So if I can annotate here, it will be easy for you guys to follow. Okay, so now I'm dividing this into two boxes, right? So this is the on-prem side. Okay, so and this guy, the dotted line that you see here is your VNet, is your virtual network. So we talked about the ExpressRoute, right? So uh, when you have these on-prem network and then you want to connect them to the VNet using a private line or uh, a dedicated circuit, which is, by the way, not encrypted. So you have to remember these circuits that they're providing are not encrypted. That's the same case uh, with AWS Direct Connect. It's not a encrypted line. But anyways, so this is how they connect, right? So you have the customer router, and then you go to provider like Equinix, AT&T, Verizon, CenturyLink, and then you ask for this ExpressRoute circuit. So they will connect you to their router, right? That's the provider edge router. And then there are a set of Microsoft edge routers as well, which they connect to. And these routers are responsible for bringing your circuit into VNet, into the cloud, okay? So they do all this background work, and then you land into this VNet, which in our case, you can think of it as hub VNet, because we have some other VNets connecting to this guy, and yeah, that's where you land. Okay, so yeah, so when you land into this VNet, you land into the ExpressRoute gateway. So that's the logical construct they have inside VNet. And then you come into the VNet, and then from here you have the Azure firewall. You can go to um, other VNets using some NVA, right? So customers are using, for example, Aviatrix here to deploy the Aviatrix transit gateway and then connecting their VNets together, or for the routing and for transit functionality. Okay. Okay, so now I can. Okay, so now we are on the topic of transit, because transit, like I said, is very important. And the solution that we have actually, the architecture, the platform is actually uh, available or helping customers both in greenfield and brownfield. So if you have already deployed VNets, VPCs in AWS, for example, and if you are facing those challenges, we can actually work with you and then provide you the architecture or enable the architecture even for the brownfield as well. A lot of times we see greenfield, they come with us with a one pane or certain pane, but what we recommend to them is an architecture approach, like I said before, right? And the architecture approach, it starts with the transit because that is the most important thing in the architecture. So if you look at the native options that Azure provide you, you will notice that they have three different options. Okay, so for the inter and for intra-region transit, right? And this is where it is very why that's why it's very complicated, and that's why customers actually they like our model better because when we provide this transit solution to customers, it's seamless. You don't face all these challenges that I will explain to you in couple of slides, right? So they have the transit option via ExpressRoute Edge Router, and then you can also use some NVA in the Hub VNet, or you can go with the VNet Peering. Okay, so let's take a look at them one by one. Okay, so the transit with ExpressRoute Edge Router, right? So that's and this is what customers actually Azure customers started doing basically. So they have this VNet 1, VNet 2, and then other VNets. And when it comes to providing the transit solution, what they thought that why not use this Express Route Edge Router to provide transit functionality between those VNets, right? So this is their common way to start with the transit solution. And but the problem is that this is very limited. It has so many limitations. For example, when you enable this feature or transit, it's default any to any spoke. So everyone will talk to everybody, right? And then you don't have visibility and control. It's very limited. Another thing that you will notice that this is not officially documented, right? So using express route edge router as a transit is not a documented feature, and this is something Microsoft does not encourage. But a lot of customers are using it, and Microsoft support them. But yeah, that's a different story, right? So what the another problem that you see here that in order for this all this to be done, you have to advertise either a default route or some kind of a summary route so you can attract all the traffic, right? So this is where a lot of hair-pinning issues are coming in, and these express edge routers are basically shared resource, right? So there is a noisy neighbor problem. It's some customer if they start pumping too much traffic, then yeah, you might see some performance issues there. The second option is with the NVA, right? So this is what customers use, the network virtual appliance. And typically what I have seen customers deploy some kind of a firewall in the NVA, and that's what they use for transit purposes or some other third-party solutions like other virtual machines or the providers who are providing the NVA in this transit space, right? But again, the problem I see with those solutions that it's not very scalable, right? The high availability is all manual, and if you're using the firewall here in this space or in the transit, then basically you're talking about source netting the traffic, right? So you lose the visibility. Um, the bandwidth issues I see are limited for when I see third-party NVAs there, right? And then the management of those UDR, the static routes, to point this VNet towards this, point this guy over this. When you bring something else, then you have dealing with all the manual UDR thing, right? So that becomes a really challenging issue for enterprises. The third option is VNet peering. So this is preferred method by Microsoft product group, but like I said, for enterprises, it's not really an option. You have to create this one-to-one mapping. You are creating this full mesh. It does not scale. There are visibility issues there, and let's say if you want to change something in the subnet or change the CIDR, then you need to break the peering, and then you need to add the CIDR and then repeer again. So yeah, that's not really an enterprise grade option. So for the inter-region transit solution, pretty much same options are also available with their associated issues, right? So I'm not going to go into the details of each one of them, but yeah, the problem actually remains, right? So that's what I'm trying to tell you. So you really need to look at Aviatrix solution to avoid all those issues that I talked about. Okay, so now they know that these are the issues with the transit. Like I said, transit is not easy. Coming up with a transit solution in cloud core is not an easy problem to solve. So that's why you see so many iterations even within Azure. So now they have this thing called virtual WAN, which supposed to solve those problems, but unfortunately it is not. So if you look at this virtual WAN architecture, what they are doing here, they are providing you this vWAN hub, right? So they are managing it. This is their entity, their service that they provide. But it's not, first of all, not multi-cloud friendly, right? So we know that already. So it's only there in their Azure. Um, and the cost is another factor. So the customers I talked to or the documentation I read, it says that when you're purchasing vWAN solution, you have to buy all the features, right? So the cost could be something that you need to think about if you're thinking about deploying it. It does not support any third-party devices in this hub location, okay? And troubleshooting and visibility is again a problem, right? So those are the some problems I see. And then beyond that, if you look at or peel the onion even more, you see more issues. So for example, when you enable vWAN feature, then all these branches or headquarters, they will start talking to each other, right? So you basically cannot control the routing policy or the way you want to engineer your routing domain. It's very difficult, right? And then if you peel the onion even more, you will see that, yeah, for Azure to on-prem, they from Azure to on-prem, they have only 200 BGP route limit. That's a huge limitation in my opinion, because think about this solution, the vWAN solution. You enable it, and all these branches, they started talking to each other. They started sending those BGP routes or prefixes. And and you're saying that only 200 BGP is the limit, right, from Azure to on-prem. And if you send the 200 first route, it will actually cause the whole ER or ExpressRoute to just drop, right? So there are no alarms or nothing. So those are the issues that we see, and these are the issues we are trying to solve for our customers, which are in the space of manageability, even deployment, or for the when it comes to operations and running the show basically.